Hello, and welcome to this series of videos where we will be talking about the linear algebra, which is a mathematical tool for the practical understanding of quantum mechanics. So, about 6 to 7 videos in this series will focus on the mathematical part of quantum mechanics before we dive into the actual concepts of quantum mechanics. To begin with, numbers are distinguished as natural numbers, which is, as we know, zero starts from zero and goes counting above. Then we also have integers, which also represents numbers in negative, so less than zero. This get extended into rational numbers, such that where we have numerator and denominator, where a denominator may belong to an integer and the denominator may be any number from the natural series. You also have real numbers, which have their purposes both for the rational and irrational categories of number. So in terms of rational number, there is still be combination of integers and natural number, but they also extend to irrational number, which are not directly used, for example, pi or the Euler's constant E. In terms of the further extension to this, there are imaginary numbers, which are not directly countable or measurable, but they are used in certain concepts in electrical engineering and physics. And they can combine with real numbers to formulate something which we call as complex number. But how does this imaginary part represented? This imaginary part is represented as a square root of -1. That means I square is equal to -1. This particular equation is used to satisfy certain problems in electrical engineering and physics, and holds a very special meaning in that context. In terms of extending the imaginary part, as I said, complex number comes into play, where a complex number has both an imaginary part but also a real part. That is the way in which complex number helps you to solve certain problems which would otherwise be intractable or unsolvable in nature. How does a complex number being represented? It's represented in the format of z is equal to a plus bi, such that both a and b coefficients are part of the real number group, and z becomes the part of complex number series with the imaginary part represented by I. There are certain examples that's given here for better understanding. This is a short video, and you will have many more short videos in this series to try to extend the concept on the linear algebra. So I'll stop here, and I hope to see you in the next video. Thank you very much.